Welcome to the Discrete Universe podcast.
Great to be here.
Today, we're really getting into a pretty fascinating idea at the heart of quantum geometry dynamics, QGD for short.
That's right. We're going to break down this concept called the directional sum.
Exactly. It's a unique mathematical operation within QGD, and it gives let's say, a fresh angle on fundamental forces interactions. The whole picture, really.
And especially for those of you listening with a physics background, we'll explore what it is, why it makes QGD stand out from, other theories.
How it's actually used, how QGD applies it to explain some, frankly, huge cosmological mysteries.
We'll be drawing on QGD's core ideas, its predictions about gravity, cosmology, even its fundamental take on space and time itself.
Okay, so let's dive in. QGD, it starts with this foundational idea. Space isn't continuous. It's not smooth.
Right. It proposes space is fundamentally discrete, made up of these basic units called preons plus,
And
three
yeah,
piles.
it's kind of the ultimate building blocks in this framework.
And matter then arises when these preons plus specifically bind together. There's an attractive force involved they call P gravity.
So P gravity is what holds these preons plus together to form matter at this super fundamental level.
That's the idea. And what's really interesting is how this discrete view changes how you think about momentum.
How so?
Well, in QGD, an object's momentum isn't just one single vector quantity. It's seen as the sum, the combined momentum vectors of all the individual preons, plus making up that object.
Ah, okay. So it's immediately a much more sort of granular way of looking at it compared to classical physics.
Definitely. And this is where it gets even more interesting. When particles interact, say, via this P gravity,
Yeah.
the momentum of each preon plus inside those particles doesn't just, change magnitude or the overall direction of the whole group changes. No, the direction of the momentum vector for each individual preon plus gets adjusted by the interaction.
Wow. Okay. So it's like a really complex, microscopic dance of momentum vectors changing direction at the most basic level.
Exactly. A kind of choreography, like you said. And the directional sum, that's the mathematical tool QGD uses to keep track of all these individual directional shifts in momentum happening during interactions.
So it's not just adding up the total momentum before and after, like a standard vector sum might focus on?
It's much more detailed than that. It specifically tracks how the interaction reorients the momentum vector of every single preon plus involved.
Okay, I think I'm getting it. It's a fundamentally deeper level of analysis than just looking at the net change for the whole particle or object.
That's the key distinction. In standard physics, vector sums are obviously crucial for momentum, but the focus isn't usually on the momentum changes of the truly fundamental components during an interaction. QGD, with the directional sum, puts that right at the center.
So gravity, for example, wouldn't be seen as just a force pulling on a whole object.
Exactly. It's seen as the collective outcome, the cumulative effect of all these tiny directional momentum shifts happening at the preon level. That granularity is absolutely fundamental to how QGD sees forces working.
Okay, so the directional sum is this core operation in QGD, tied directly to its discrete view of space and matter. But what makes it so, unique to QGD? How is it different from how other theories handle momentum?
Its uniqueness really stems right from QGD's basic axioms, its foundational principles. Think about that discrete space again.
Right, no continuous spacetime fabric as the fundamental thing.
Precisely. So interactions happen between these discrete preons involving exchanges of their momentum. The directional sum becomes almost a necessary mathematical language if you want to describe these interactions accurately within that discrete framework.
It's the natural way to track changes in a reality that's fundamentally granular.
That's a good way to put it. And it's also deeply connected to another core QGD principle, strict causality.
It's a causality,
Meaning that every state of a particle is strictly and uniquely determined by the state immediately before it. There's a direct, unbreakable causal link. The directional sum provides the mathematical mechanism to ensure the strict link holds true, even during complex interactions, right down at the preon level.
Ah, I see. So it allows QGD to precisely map how the system of preons evolves from one moment to the next, based purely on these directional momentum changes.
Exactly. So the directional sum isn't just some, convenient math trick. It's a direct reflection of QGD's core beliefs about reality, its discreteness, and this principle of strict causality.
That makes sense.
And there's more. QGD puts a lot of emphasis on invariance, fundamental properties that are conserved that don't change at the most basic level.
Like momentum energy.
Right. The directional sum acts as the bookkeeper, essentially. It tracks these conserved properties like momentum, but specifically at the individual preon level, making sure everything adds up correctly throughout any interaction within this discrete picture.
Okay, now this is where it really starts to challenge maybe the standard ways of thinking. How does this directional sum concept lead QGD to explain something like gravity? We're used to fields, space-time curvature.
Yeah, it's a different approach. QGD basically derives gravity from the sum total of all the tiny variations in the momentum vectors of the preons, plus within objects that are interacting. The directional sum is the math that describes this.
So imagine two objects,
Uh-huh.
lots of preons, plus.
Right. The p-gravity between all their individual preons causes continuous, instantaneous shifts in the directions of their momentum vectors. The directional sum calculates the cumulative effect of all those microscopic reorientations, and that's what we experience as the macroscopic force of gravity.
Hold on, instantaneous action. That sounds very different from general relativity, where gravity propagates at the speed of light.
It is. That's a major point of difference. QGD proposes gravity's influence is immediate. No speed limit, no propagation delay.
But how does that square with observations like gravitational lensing or the weird orbit of Mercury? Aren't those key proofs for relativity?
Well, here's the thing. QGD claims that this instantaneous action, combined with how mass warps space in the QGD framework, which is different from GR's curvature, mind you, actually predicts things like lensing and Mercury's precession quite well.
The QGD gets the right answers for those key tests, but with a fundamentally different mechanism that doesn't involve gravity traveling at light speed.
That's the claim. It's a radical shift in perspective.
And what about gravitational waves, if gravity is instantaneous?
Right. QGD doesn't have gravitational waves as ripples in space-time. Instead, it talks about preonic waves.
Preonic waves.
Yeah, think of them not as space-time distortions, but as variations in how the preonic field itself is polarized, like coordinated alignments in the directional momenta of many preons.
Huh?
And crucially, QGD predicts these preonic waves would be detectable because they transfer momentum. And that momentum transfer, again, ties right back to the directional sum of the individual preon momenta involved in the wave.
Wow. Okay, so the directional sum is really woven into the fabric of QGD's explanations for gravity and related phenomena.
Yeah.
Let's dig into some more specific applications then. How is it used across different areas?
Well, gravity itself, as we've discussed, is a prime example. The directional sum is right there in QGD's equation for gravity, and that equation does something interesting.
Which is?
It predicts not only attraction, like we normally see, but also, under certain conditions, specifically at very large scales, it predicts gravity can become repulsive.
Repulsive gravity. Okay, my mind immediately goes to dark energy. The universe expanding faster and faster.
Exactly. QGD suggests that on vast cosmological scales beyond a certain distance, the cumulative effect calculated by the directional sum actually flips gravity into a repulsive force. And that repulsive gravity is QGD's proposed explanation for the accelerating expansion, replacing the need for a separate dark energy.
So it's an emergent property of gravity itself at large scales, derived from the directional sum.
That's the idea. And it also impacts their model of dark matter. The directional sum calculations lead QGD to predict that where you find less visible matter, you'll also find less dark matter. And significantly, it predicts you won't find those very dense, sharply peaked dark matter halos, the cuspy halos, that some observations suggest but are tricky for standard models to explain.
Interesting. Okay, what about other forces, like electromagnetism? Where does the directional sum fit in there?
QGD views electromagnetism as arising from the polarization of this underlying preonic field.
Polarization meaning alignment.
Essentially, yes, aligned directional momenta of the preons plus. The strength and direction of the electromagnetic force depend on the degree and pattern of this alignment, which again can be described mathematically using the directional sum of the momenta of the preons involved.
Does that lead to any testable differences from, say, the standard model?
It does, potentially. QGD suggests there might be tiny quantitative differences in the strength of the electromagnetic interaction depending on which particles are interacting. Like proton-electron interaction might be slightly different from proton-muon interaction.
Why?
Because the specifics of how their internal preons polarize, how their momenta align, might differ slightly. And those differences, captured by the directional sum, could lead to measurable variations in the force strength.
That is specific. A potential experimental signature to look for. What about really extreme objects, like black holes?
QGD is a different take on black holes, too. They aren't singularities in this model. They're seen as incredibly powerful, polarizing objects.
Polarizing preon.
Exactly. They break down matter into its constituent preons plus, and then strongly align their momenta. The directional sum is key to understanding the intense jets we see shooting out from near black holes. QGD views these jets as streams of highly polarized preons plus, launched along the black hole's magnetic axis, precisely because their directional momenta are so strongly aligned.
And these jets themselves could have larger scale effects.
Yes, QGD even proposes that the repulsive electromagnetic force from these highly polarized preon plus jets, summed up across the universe, could contribute to the overall dark energy effect, the accelerating expansion.
It really seems like the directional sum is this connecting thread in QGD, linking particle physics to cosmology. What about quantum weirdness, non-locality, entanglement? To touch on that?
Well, within QGD's discrete space and its principle of instantaneous interactions mediated by this preonic network, the directional sum provides a potential basis for explaining effects that look non-local.
How so?
Because if a change in the gravitational interaction of one particle calculated via the directional sum propagates instantly through the preonic field, it could have immediate consequences for another particle, no matter how far away it seems in our emergent continuous space. The connection is fundamentally instantaneous at the preon level.
That's a really mind-bending perspective. It feels like QGD, with this whole axiomatic structure and the directional sum at its core, is sort of tackling a really old, deep question in physics.
You're absolutely right. It echoes, in a way, Hilbert's sixth problem.
David Hilbert, the mathematician.
Yes. Back around 1900, he posed the problem of finding a rigorous mathematical axiomatic foundation for all of physics, and specifically deriving continuum physics, our everyday smooth space and time, from some underlying atomistic or discrete model.
And QGD is attempting something like that.
In spirit, yes. By starting with axioms about a discrete reality, strict causality, and using tools like the directional sum, QGD tries to build up physics from first principles, eventually hoping to show how our familiar continuous world emerges from this deeper, granular level. It's definitely in the lineage of that Hilbert challenge.
So the directional sum isn't just some isolated piece of math. It's really a cornerstone of this whole ambitious project to rethink physics from the ground up.
Precisely. It's the mathematical engine, if you like, that allows QGD to explore the consequences of assuming a discrete universe governed by strict causality. It provides this unique lens.
A lens focusing on the directional changes in momentum of the most fundamental bits of reality, the preons plus.
Exactly. And through that lens, QGD offers these alternative explanations for gravity, dark matter, dark energy, cosmic redshift, which we didn't even get into deeply, but it interprets redshift differently too, based on discrete momentum transfers tracked by the directional sum.
Right, not just the Doppler effect.
Not just the Doppler effect. So it tackles many big questions.
And as we've seen, it raises fascinating new questions and makes some very specific, testable predictions, things that could potentially really distinguish it from established theories down the line.
Which is what makes it exciting, even if challenging.
Absolutely. So we really encourage you, the listener, to maybe mull over these ideas from quantum geometry dynamics. Think about the implications of a world that's fundamentally discrete, ruled by strict cause and effect, and this concept of the directional sum.
What else could this framework potentially explain? What kind of experiments might push these ideas further, either confirming or challenging them?
Lots to think about. Thank you for joining us on this deep dive into the discrete universe.